Let me start by reviewing the sine and cosine function. We have the unit circle, and then for every angle, there is a point in the unit circle that goes with it. Remember, this is the initial rate, this is the final rate, and this is the terminal point in the unit circle. The coordinates are x and y, and x is cosine of the angle. This is the angle, and the y is sine of the angle. There is some like quotients of these functions that produces other functions. We have the function tangent of theta, and by definition it's just sine of theta over cosine of theta. We have cotangent of theta, which is just the reciprocal. That means cosine of theta over sine of theta. We have secant of theta, which is the reciprocal of cosine of theta. That means it is 1 over cosine of theta. And we have cosecant of theta, which is the reciprocal of sine of theta, 1 over sine of theta. Notice that the domain of the function sine and cosine is the whole real numbers. For every angle we can find sine and cosine, but for every angle we cannot find tangent or cotangent. The reason is that in the definition we have a denominator, and that denominator could be 0. That means that, for example, tangent of theta, what is the domain of tangent of theta? It is any angle as long as the angle doesn't make cosine of theta equal 0. For example, 90 degrees, if we are talking about degrees, or pi over 2, is not part of the domain of tangent of theta, because cosine of 90 degrees is 0. Remember, this is the point 0, 1, and therefore x, which is cosine of 90 degrees, is 0, and that will make this denominator equal 0. Same thing happens for the other functions. It is easy to tell what values. Just look at the denominator and decide when that denominator is equal to 0. If the denominator is equal to 0, it's not part of the domain of that function. Let's talk a little bit about the name of the functions. We have sine, cosine, tangent, cotangent, and secant, cosecant. It's like the co-function of something. For example, the co-function of sine is cosine, and the co-function of cosine is sine. They go in groups like this. Cosine of theta, sine of theta, cotangent of theta, tangent of theta, and secant of theta, and cosecant of theta. They are called cofunctions. These two are called cofunctions. It's like if they are like siblings, right? This is the sibling of this is the sibling of this, but they are the cofunctions. And they have to do with something that is called complementary angle. Then we say that the complement of an angle is just 90 minus the angle. Then let me write that down. The complement of an angle is 90 degrees minus the angle. Or if we're talking in radians, it will be pi over 2 minus the angle. Or we can say that two angles are complementary if the sum, when we are talking about degrees, if the sum is 90, or if we are talking in radians, if the sum is pi over 2. Then we have the notion of cofunction, and we have the notion of complementary angles. A picture of complementary angles, if they are acute angles are those that are smaller than 90, bigger than 0. If this is theta, the complement is this one. The sum is 90. But then the connection between complementary angles and cofunctions is that if you have cosine of 10 degrees, what is the complement of 10 degrees? 80 degrees. Then this is the same as sine of 80 degrees. Then a function evaluated at an angle is equal to the cofunction evaluated in the complement. Let's do more examples. Sine of 75 degrees is the same as cosine. What is the complement of 75? It would be 15 degrees. Or tangent of 35 degrees is the same as, what is the cofunction of tangent? The cofunction of tangent is cotangent of, what is the complement of 35 degrees? The complement of 35 degrees is 55 degrees. We can check this with the calculator that these things are the same. Same thing with secant and cosecant, they are cofunctions. And then, for example, we have that secant of 20 degrees is the same as cosecant of 70 degrees. Then we can change the a function with its cofunction, but we have to change the angle with the complement. Then this is the connection between cofunctions and complementary angles. These are the other 4 trigonometric functions that we can define, and then all together we have the 6 trigonometric functions. Let's do an example about how to compute tangent of an angle. Let's say tangent of 45 degrees. For 45 degrees, we have that it is this line here, right? And then in this case, the terminal point, we can fit here a right triangle. And we can use this right triangle here, 1, square root of 2 over 2, square root of 2 over 2. 45 degrees is in the first quadrant. That means that the x and the y are positive. And then this number is the square root of 2 over 2, square root of 2 over 2. And that means that sine of 45 degrees is a square root of 2 over 2. And cosine of 45 degrees is the x, is the square root of 2 over 2. And therefore, tangent of 45 degrees, which is sine over cosine, it is just 1. Notice that we already know how to compute sine and cosine, especially for the special angles. For the non-special angles, we need to use a calculator. But then, for every angle that we know how to compute cosine and sine, we would be able to compute the other 4 functions because they are just in terms of sine and cosine. Let me explain some relations between reflections of angles and the value of these trigonometric functions. Let's talk about the reflection about the y-axis. Then essentially, if we have an angle, suppose that we have the unit circle, and then we have an angle, then let's say we have this angle, theta. Then the reflection about the y-axis is just this one. It's like the y-axis is a mirror, then you got this angle here. Notice that if you compute this angle here, let's call it beta, then this beta must be equal to this beta for the reflection. Then, for example, if this is 300 degrees, right? Then this is 300 degrees, and therefore, if this is 300 degrees, remember that this is 270. That means that this beta is 30 degrees. This is 270, and therefore you have to come back 30 degrees, and then you will be 240 degrees. Then the reflection about the y-axis of an angle, in this case of 300, it will be 240. Notice that this formula will work for the reflection about the y-axis. If you have an angle, then the reflection about the angle is 180 minus the angle. Let's check this formula in this case. If we have 300, then what is 180 minus 300. 180 minus 300 is negative 120. And negative 120 is the same as, if you are 360, is coterminal with 240. Then this formula will always work for the reflection about the y-axis. The important property about the reflection about the y-axis is that sine of any angle is the same as sine of the reflection about the y-axis. This is the important property about the reflection about the y-axis. And the reason is that when you think about the terminal point here, when you think about the component x and y, let's suppose that this is x1, y1, and this is x2, y2. When you are doing the reflection about the y-axis, the values for y, they are the same. Remember that we're in the unit circle. That means that the sines of this angle and the sine of this angle, they are the same. The cosine changes, but the sine are the same. Okay, this is the reflection about the y-axis. Let's look at the reflection about the x-axis. Reflection about the x-axis. Let's think about an angle. Then if you have this angle here, let's say that this is 135 degrees, then the reflection about the x-axis is pretending that this x-axis is a mirror. Then the reflection would be something here, is this angle with the property that this angle is the same as this one. For example, for 135 degrees. For 135 degrees, this angle here is 45. Remember, this is 180, and therefore this angle is also 45 degrees. Then the reflection about the x-axis of 135 is 180 plus 45, which is 225. Then the reflection about the x-axis of 135 is 225. There is an easier way to remember this. The reflection about the x-axis of an angle theta is just the angle negative theta. Let's check this with this example. If you have 135, then we say the reflection is negative 135 degrees. Look at this. This is just, when you do negative 135, you will reach here. If you want to check that is the same as 225, you just add 360. These two angles are coterminal, and you will get 225. Okay, and the important property about the reflection about the x-axis of an angle is that when you have cosine of any angle, is the same as cosine of the reflection about the x-axis of that angle. Let's say the reflection about the x-axis of the angle. Then this is the important property. Cosine doesn't change. And the reason is that if you think about this terminal point, x1, y1, and you think about the one that goes with the reflection about the x-axis, x2, y2, then we can see that the x1 and the x2, they are the same. Then that means that the cosine is the same. Finally, let's do the reflection about the origin. For the reflection about the origin, we have the following. If we have an angle here, let's say 100 degrees, then the reflection about the origin is just, you just like flip this about the origin, then you get this angle. Then if this is 100 degrees, that means that this is 90, then this is 10 degrees, and that means that this is 10 degrees. And therefore here this angle should be, this is 270 degrees, and this is 280 degrees. Then the reflection about the origin of 100 is 280 degrees. There is an easier way to do it without looking at the picture, and is that if you have an angle theta, to find the reflection about the origin, there are two possibilities. Either one will work. You just add 180 degrees if you are working in degrees, or you just subtract 180 degrees. Either one will work. For example, if we have 100 degrees and you want to do the reflection about the origin, then I can just add 180. 100 plus 180 is 280. If it is more convenient to you, 100 minus 180 will also do the job, and this is negative 80 degrees, which is coterminal with this one. Negative 80 degrees give you that. And the important property, and one important property about the reflection about the origin is that if you have tangent of an angle, this is the same as tangent of the reflection about the origin. Then this is the important property for the reflection about the origin. Tangent of an angle is the same as tangent of its reflection about the origin. You can check with your calculator. If you compute tangent of 35 degrees and you compute what is the reflection about the origin, one way to do it is 35 degrees plus 180. This is 5, 11, 215 degrees. And then you can check that tangent of 35 degrees is just tangent of 215 degrees. That's an easy to check. Remember that if you are working with radians, then the formula will be theta plus pi, because pi is 180 degrees, or you could use theta minus pi, because pi is 180 degrees. These are the two ways to compute the reflection about the origin of an angle. And the important property about the reflection about the origin is that tangent of an angle is the same as tangent of the reflection about the origin. Remember, the important property about the reflection about the y-axis is that sine of an angle is the same as sine of its reflection about the y-axis. And the important property about the reflection about the x-axis is that cosine of an angle is the same as cosine of its reflection about the x-axis. Okay, this is it for this video.